Hello, this is Dr. Fitzgerald. In this video, we want to discuss factoring by removing the greatest common factor. So let's look at an example. We want to factor 6x cubed minus 4x. So when removing the greatest common factor, we want to remove the largest factor that each term has in common. So the way I like to look at this is I like to look at the coefficient and then the variable. So let's look at the coefficient first. We have a 6 and a 4. So when trying to figure out what can be removed, what can be divided, what's the largest number that can be divided by both of these numbers evenly? So we can take out a 2. A 2 goes into 6 and a 2 goes into 4, and that evenly, and that's the largest number that we can do that with. So we want a 2. Then let's go to our variables. I see that we have an x to the third power and an x to the first power in this case. So we want the largest amount that each individual term has. And the way that works out is that typically ends up being the variable with the smallest exponent, And notice, because this is x to the first power, that is the one with the smallest exponent there. So we want to remove 2x. When I remove 2x, the quantity that will be left would be 3x squared, because if I remove a 2x from this, I'll be left with a 3x squared, minus a 2. And we can always check this by multiplying or distributing that 2x back. We should always get that. And another hint, if this is 2 terms, I should always have 2 terms left on the inside. I always need the 2 terms left on the inside. And that is factoring using the greatest common factor. Let's look at another example. So here we want to factor minus 4x squared plus 12x minus 16. So once again, let's look at our numbers. Let's look at the coefficients first. And we have a -4, a +12, and a -16. Since the leading coefficient, that is my -4, since it's a negative, we want to also factor out the negative sign. So here we can factor out a -4. Why is that? Because -4 is the largest number that goes into 4, 12, and 16. Then we want to check for the variables. Here I have x to the second power, x to the first power, and 16 doesn't have an x at all. So since 16 doesn't have an x at all, we can't factor out an x. Remember, when removing the common factor, each term must have that factor. So -4 is our greatest common factor. Now let's see what's left. If we remove a -4, that's like dividing this term by a -4, we're simply left with an x squared. Plus, if I remove a -4 from 12x, I will be left with a +3x. And lastly, if I remove a -4 from 16, we end up with a +4. And let me change this sign here, because remember, we removed the negative, so we must be careful. When removing the negative, our signs will change. So this has to be a negative. And how would I know that? I can go back and double check my answer by multiplying, that is taking this -4 and distributing it back through, and I must get the original problem. So make sure we double check those steps and make sure that we do that correctly. And this would be our final answer for this problem. Let's look at one last example. Here we want to factor the quantity 3x to the 4th y squared plus 9x cubed y plus 6x squared y cubed. Now we want to use that same strategy. Let's look at our coefficients first. So when looking at our coefficients first, we have 3, 9, and 6. So the largest number that can be divided into each of these numbers evenly is a 3. So I can factor out a 3. Now let's look at our x variables. X to the 4th, I see I have an x cubed and an x squared. And remember, we said the way this works out is when we're moving that, we really want the variable to the lowest power. And we see that the lowest power of the x's really is 2. So that's the power that we want. So we want x squared. And then next we have y squared, y, and y cubed. And in that particular case, the lowest power of y is y to the first power. So we want y. Now we want to see what's left. When we're removing 3x squared y, let's look at it piece by piece. When we're removing a 3 from 3, that goes away. But when we're removing an x squared from an x to the 4th, we're left with an x squared. Remember, x squared times x squared has to give me x to the 4th when multiplying back. When taking a y away from y squared, we're left with y. Next, when taking a 3 away from 9, or dividing 9 by 3, we're left with a 3. When dividing x cubed by x squared, we're left with an x, and our y, when taking y from y, that goes away. Lastly, we're left with a 2, no more x squareds, and 1y is left. So this would be our final answer for this problem. Now this is removing the greatest common factor, or factoring using the greatest common factor. Thank you.